Thanks, everyone. And thanks for Daria for organizing this session. This is a collaboration with Derek Shook, who's at the Water Resources Division of the National Park Service in Fort Collins, Colorado, and David Cooper at Colorado State University. And I'll be talking about monitoring short and long-term vegetation changes following wet meadow restoration in Drakesbad Meadow in Lassen National Park. So why do we care about wet meadows? Well, they provide vital habitat for wildlife. They also filter water and provide storage of the water. They slow the water movement down through the watershed. And they also form an important, they're an important player as a carbon sink. And historically, many wet meadows throughout the Sierra and the Cascade Range have been drained for grazing. And such is the story of Drakesbad, so I'll just jump right into that. So here is, let's see here, Lassen National Park here in Northern California. Drakesbad Meadow, if you've never been there, you go to Lake Almanor or Chester and you head north. It's not off of the main drag in the park. And it is the largest wetland within Lassen National Park. It's about 82 acres in size, and it sits at about 5,500 feet in elevation. It's fed by a large perennial groundwater complex that is on the northeastern slope here. And so the groundwater comes down and comes into the meadow, and then everything flows east out. Hot Springs Creek flows east this way as well. And since from the late 1800s until the park acquired the land in 1958, the guest ranch, the owners of the guest ranch used the meadow for as a pasture, and so as such they drained it. They constructed irrigation ditches throughout the meadow, and they also removed a lot of the shrubs. And let's see. Oh yeah. So historically, the water would flow as sheet flow through the meadow, but with the irrigation ditches that were present, that was no longer happening. And even though grazing stopped in 1958 when the park acquired the land, there were still remnants of the historic grazing. So there's one of the incised ditches that you can see. And so this project actually started back in 2002. It was started by David Cooper and a master's student, and they worked with the park to develop a pilot study essentially. And so in 2002, they did pre-restoration vegetation and groundwater surveys. They installed 87 groundwater monitoring wells throughout the meadow and monitored and collected data on the vegetation. And then they initiated the pilot study in 2003 which included sheet metal dams, which they installed along some of those irrigation ditches, as well as some water bars that were installed across the road. And that occurred in late summer. And then in 2004, 1 year after that restoration, they went out and looked at the vegetation response and did groundwater surveys. And that paper is published. It was published in 2007. And so here is the meadow. The black lines here show the ditches, the irrigation ditches throughout the entire meadow. These dots here are the groundwater monitoring wells. Those are not obviously the 87 groundwater monitoring wells that they installed. These are the ones that we could find in 2017. So the water bars that they installed were along the road here to the water tank, pretty close to where the current culverts are located. And then they put in sheet metal dams along one of the ditches here. There were 5 of them that were located along this ditch here. And they saw really great success 1 year post-restoration. So they saw increases across the meadow of the groundwater levels. And they also saw subsequent increases in obligate wetland species and decreases in facultative wetland species. So with that, they decided that an increase, or to go forth with a larger, more permanent restoration plan. So in 2012, Cooper and the park folks identified priority ditches that would be filled and did groundwater surveys, and then they filled the priority ditches and they removed the causeway in the fall of 2012. And then in 2013, they did post-restoration groundwater surveys. It was too dry when they went out there to do vegetation surveys, as it was the middle of the drought. So no vegetation surveys were done in 2013. The causeway here was a path. It was an elevated path, and you can see here these ditches cross the path in two locations. And so they removed this causeway and they built an elevated boardwalk, so that would allow the water, once they filled these ditches, to just go as sheet flow through the entire meadow complex, as opposed to just through within the ditches. So the ditches that were filled in fall of 2012 were filled with some soil that was from a road construction project. So they filled the ditches, and here they are filling the ditches, and then they removed the causeway. And then in spring of 2013, this is what it looked like. There was no more water that was just going right into the ditches. It was more spread out across the meadow. And so that brings us to my portion of the project when I picked up the field work. So in 2017 and 2019, we went out and did post-restoration vegetation and groundwater surveys in both of those years to try to answer these two research questions. So, have growing season groundwater levels increased sufficiently to promote increased cover of wetland vegetation? And then, how has the wetland vegetation composition changed since 2002, pre-restoration, and the initial pilot study in 2003? And so, I forgot to mention, but this whole restoration project was based on the fact that you create the hydrologic conditions to allow for passive vegetation restoration. So no planting was done here. This was all just active hydrologic restoration by filling the ditches, and then what came back was just what was there originally, or that was the hope. So in the summer of 2017 and summer of 2019, we did groundwater surveys. So bi-weekly measurements, hand measurements of 35 of the groundwater monitoring wells, and then monthly in 2019. So 4 to 7, depending on the year, had loggers installed in them. So we got continuous measurements of the groundwater change over the growing season. And then we followed the methods that were originally done for vegetation surveys, which were 10 square meters circular plots around the wells, and those were sampled in late July, so around 24 wells. For analyses, and what I'm going to show you today, I'm going to show you some changes in the groundwater levels over that entire period, as well as some changes in vegetation. I've grouped the vegetation based on the U.S. Army Corps of Engineers wetland indicator status, so that you can see whether obligate species increased and facultative species declined, rather than look at specific species. So I just want to acknowledge that over the course of this 17 years of this project, we've seen the driest year on record and the wettest year on record. So this is the Snowtell Station at Harkness Flat, so just east of the Meadow. And the SWE, the snow water equivalent on April 1st in 2013 was 20 centimeters, and then last summer it was almost 120 centimeters. So there's been a huge range of available water for this system over this period. So keep that in mind. All right, so some results here. I'm going to focus in on these two wells here, 4 and 12. They're located on the eastern side of the meadow, close to where these ditches are filled. So the solid black lines here show the filled ditches. The dashed lines are ditches that are still out there. They were unfilled. They were not as high priority. So with well 4, so that's the farthest east, this is continuous data over the growing season. So what you can see here, there's month on the x-axis. The water table depth is on the y. So at 0, this is ground surface here, and then this is all water, depth of water below ground. The bottom of this well here is at just under, or just over 40 centimeters, so it's not a very deep well, but that's why that line levels off. But what I want to point out here is that those colored lines show, those are all of the years that are pre-restoration, so before the ditch was filled. The black lines are post-restoration. So 2013, 2017, and 2019 are all post-restoration. The groundwater levels stayed high during the entire growing season. Even during 2013, which was a pretty dry year. We also see a similar trend with well 12. So that was just west of well 4. The colored lines show sharp declines over the growing season, whereas after restoration occurred, the groundwater levels stayed high throughout the growing season in all years. So that's pretty encouraging. If we look at the hand measurements, so those are just 2 of the wells. 19 of these wells have good data for the entire study period. And so I created this inverse distance weighted interpolation of groundwater. This is looking at just mid-July depth to water. And what this is showing here is blue areas show higher groundwater levels post-restoration. The yellow and the brown areas show lower water tables after restoration. This is just showing the groundwater here. So you can see on the eastern side of the meadow, we have higher groundwater levels that are closer to the filled ditches. Farther away from those filled ditches, closer to the unfilled ditches, we see potentially lower groundwater levels. So how does this line up with the changes in vegetation? Well, I created a wetland vegetation metric that looked at the relative proportions of obligate, facultative, and facultative wetland species as well as facultative upland species, and just look at the relative changes over time. And so what this is showing is the change pre-restoration to post-restoration. So plots that are blue there show that the vegetation shifted more towards obligate species. Plots that are brown are the opposite. The vegetation shifted more towards drier species. So the changes in the vegetation composition really corresponded pretty nicely with the changes in the groundwater. So let's look at a couple plots in particular here. So this is that well 4 where we saw the high groundwater levels over the entire growing season post-restoration. So in 2002, the plot was actually dominated by a bunch of grasses. So Grostis gigantea, Corvium brachyopteran, and very little Carex nebraskensis. By 2017 and 2019, the Carex heavily dominated. So the vegetation completely shifted with higher groundwater levels. On the flip side, though, we see a plot that shifted towards more dry species. In 2002 and 2004, this plot was dominated by 3 different Carex species, nebraskensis, simulata, and utriculata. And by 2017 and 2019, we see a decline in the groundwater, and we also see a change in the vegetation. So it became more dominated by species that were, the only obligate species that was pretty much left in that plot was Carex nebraskensis. So over the 17 years of this project, we're just starting to kind of piece this all together, but we kind of think that the changes in the vegetation that we're seeing towards the eastern part of the meadow, these changes in the vegetation are likely due to the changes in the restoration. So we see higher groundwater levels, we see change in the vegetation. The changes that we see on the other side of the meadow here could be changes due to potentially climate. It's definitely getting a little bit drier out there. It could also be due to changes because there are still ditches out there that are unfilled. And it could also be due to changes due to the access roads still being present and blocking that groundwater flow from actually making it all the way to the meadow. So to get back to my research questions, the first research question, did the growing season groundwater levels increase? Yes, in some areas where we're close to the ditch, it definitely did, but farther away from the ditches, not so much. And how does the wetland vegetation composition change? Well, vegetation changes corresponded to changes in hydrology. So where the water tables went up, you had more obligate species. Where the water tables went down, you had more facultative species. Now this isn't groundbreaking science, right? But one of the things that I kind of take out of this is that showing just the importance of long-term research on restoration sites. So maybe you see initial changes early on in the project, but they might not stay the entire time. The second one is that this is all passive restoration. We did no planting. And so we were able to see these changes with the vegetation in the eastern part of the meadow just simply by restoring hydrologic conditions. So that was fairly exciting. Some acknowledgements here. Lindsay Patterson was a master's student. Betsy Harbert helped me with the vegetation sampling. And then some students at Chico State and staff at Lassen. And I think I might have time for one question or so.